MongoDB write concern is an acknowledgement mechanism that developers can add to write operations. Higher levels of acknowledgement produce a stronger durability guarantee. Durability means that the write has propagated to the number of replica set member nodes specified in the write concern. The more replica set members that acknowledge the success of a write, the more likely that the write is durable in the event of a failure. Majority here is defined as a simple majority of replica set members, so divide by 2 and round up. The trade-off with increased durability is time. More durability requires more time to achieve the specified durability guarantee, since you have to wait for those acknowledgements. Let's go over the available write concern levels. A write concern of 0 means that the application doesn't wait for any acknowledgements. The write might succeed or fail. The application doesn't really care. It only checks that it can connect to the node successfully. Think of this like a fire and forget strategy. Very fast, but with no safety checks in place. The default write concern is 1. That means the application waits for an acknowledgement from a single member of the replica set, specifically the primary. This is a baseline guarantee of success. Write concerns greater than 1 increase the number of acknowledgements to include 1 or more secondary members. Higher levels of write concern correspond to a stronger guarantee of write durability. For example, I can set a write concern of 3 to require acknowledgement from all 3 replica set members. Majority is a keyword that translates to a majority of replica set members. It's a simple majority, so divide the number of members by 2 and round up. So this 3-member replica set has a majority of 2. A 5-member replica set would have a majority of 3, so on and so forth. The nice thing with majority is that you don't have to update your write concern if you increase the size of your replica set. There's also a write concern level for replica set tags. That's a little advanced for this course series, but you can check out our documentation on write concern for more information. We're just talking about replica sets in this lesson. But MongoDB supports write concern for both standalone and sharded clusters. For sharded clusters in particular, write concern is pushed down to the shard level. Finally, I want to make it very clear that no matter what write concern you specify, MongoDB always replicates data to every data-bearing node in the cluster. Write concern is just there for you to have a way of tracking the durability of inserted data. There are 2 additional write concern options that MongoDB provides. The first is W timeout. This lets you set a maximum amount of time the application waits before marking an operation as failed. An important note here. Hitting a W timeout error does not mean that the write operation itself has failed. It only means that the application did not get the level of durability that it requested. The second is J, or journal. This option requires that each replica set member to receive the write and commit to the journal file for the write to be considered acknowledged. Starting with MongoDB 3.2.6, a write concern of majority actually implies J equals true. The advantage of setting J equals true for any given write concern is that you have a stronger guarantee that not only were the writes received, they've been written to an on-disk journal. If you set J to false, or if journaling is disabled on the MongoD, the node only needs to store the data in memory before reporting success.